there is few things discuss. Yes, that was the entropy. Okay, so before coming towards each anything, we can have that. What's the entropy?
Uh-huh.
So entropy is like, suppose we are having two classes, 1 and class 2. So it is having few chances inside the data. Alright,
Mhm.
and if I am having that entropy, means entropy is the chance of randomness inside my data. What is the randomness at end, or what is the deviation? Now
Mhm.
what does that mean? Suppose in first case I am having 3a in the first partition and 4b. So I can say I can go towards any conclusion, means which part will be there. And suppose in the next chance I am having 1a and 6b. So this is more, so no conclusion, means whether I should go with the with the certain direction or with certain a or certain b. But here I can have that the entropy is quite higher towards b, so I'm having 1b over here. Let me check it out. Sign in with Google. Yes, courses, machine. Here we are having building decision tree. In this video they have given very wonderful example how to take decision for the splitting part also.
Okay.
So it's not about the value only, it's about the splitting
Oh.
from where they are going to split the next node.
Mm.
Can you see my screen?
Mm-hmm.
All right. So they are having two classes over there. First is
Mm-hmm.
class A, second is class B. So which
Mm-hmm.
class will have more attribute toward A? Okay, just let me verify there. Yes, this is the yes. So in the left hand side they are going to split the classes, means the section. So on the basis of this six feature they have
Mm-hmm.
divided the training data set in the decision tree. So what they see
Mm-hmm.
that this data set is not all tend towards drug A, neither it's all turned towards drug B. Similarly, if it is there on the right hand side, so what we see that it's not completely concluding the things that what's the node part. So neither from the male side nor from the female side they can get the full conclusion that what should be the means root node over there, means leaf node going down. So
Mm-hmm.
no one can predict over there. So what they are doing, they are just more predictive, means which one is the more predicting, less purity and lower entropy. So what's the entropy means, they are going to again further they are going to based on the basis of cholesterol. So eventually they are getting that high cholesterol is leading to the drug A and drug B also. But they are explaining here the entropy, which is the randomness or uncertainty. So in the first circle, one drug A, if there is a drug A, that is quantity 1, and 7 drug B, so entropy is low. Why it is low? Because we can conclude more about B, that going down we can have B also. Is that clear?
Mm-hmm.
Similarly, entropy is high because we can predict, means which is more means concluding, means all male have should consume drug A, or all male should have consumed drug B. So I can predict from this node. Can you see this node?
Yeah.
So entropy is high means I can predict anything. So I am in the confusion state. So here I am in little bit confusion state, but entropy is quite low. This is quite, in comparison is these two, this one is the quite acceptable one. Now coming
Okay. So it's
so
kind of like a certainty level, right? I'm more
exactly,
certain that.
exactly, because
Okay.
eventually I will have to draw that root level, that is drug A or drug B. So I can't have, so
Mm-hmm.
at the leaf node I can have that that confusion part. So
Mm-hmm. Mm-hmm.
when would I say that I am going to conclude anything? Then when I will have O for drug A and all the possibilities for drug B. Means all male should have drug B, but none of the male from my data set should consume drug A. So
Yes.
in that case I will say that now I am at conclusion state, that it is going to tend towards that A. So do you remember that example in my PPT? There is a sale of
Mm-hmm.
customer buy a computer or not buy a computer.
Mm-hmm.
So those are having yes, they're just going to left hand side. Those who are having no, they were having the root node. All right.
Yeah. Okay. Yep. Makes
So
sense.
here I am having entropy is equal to 1. Entropy is always between 0 and 1. So
Zero and one.
here I am at entropy 1, which is not acceptable at all, because this is leading to me more confusion state, that
Mm-hmm.
either I should consume drug A or I should consume drug B.
Okay, so that makes sense. So that's a concept of entropy,
And
and it will apply only in decision tree, or does it apply
yes,
anywhere else?
in this decision tree, or in upcoming also, in random forest also. So
Ah,
yes, so here is the formula. We don't need to calculate this entropy manually, or a pen and paper, just jot down
mm-hmm,
nothing. So
mm-hmm,
Python code will calculate each and everything using this sample 1, 7, 3, 5, and so on. The probability of A. What is the probability of A here? Suppose I just talk about this diagram. So what is the probability of A? That is 1 upon 8.
107. Oh, 8, sorry.
8. And what is the probability of B? That is 7 upon 8.
8, yep.
Alright. So I'll just take logarithm of this value and just sum up, then I'll find out the entropy of this event only. So it will calculate the entropy of all these four circumstances, and lower the entropy, the less uniform the distribution. So
Mm-hmm,
which will have the value tend towards O. I'll accept
mm-hmm.
that one. Is that clear?
Okay,
Okay.
yes.
Now they are going to define which attribute is best out of one. So here
Okay.
they have having that patient ID, age, and cholesterol. So this is categorical data. This is not the numerical data at all. But
Mm-hmm,
on the
mm-hmm,
right hand side we can have the categorical data again. But we can have that 9B and 5A. So what is the overall entropy of this target variable? That is 0.940. Can you see that?
mm-hmm.
They are calculating using this value. And how to calculate the next entropy? So just take first variable. Okay, they have taking the first variable. Let's say it's a cholesterol. All right. So if it is cholesterol, so it will have two children only, that is normal and high,
Mm-hmm.
because two categories are there only
Mm-hmm.
when we choose cholesterol. So
Right.
out of these two, what would be the high means this one, hypothesis means, sorry, entropy will be there. So that is
Mm-hmm.
will calculate again. So with respect to drug A, would how many normal? With respect to B, how many I am having normal cholesterol? Similarly, on the high side, with respect to, and calculate the entropy again. Similarly, with respect to high means those are having high cholesterol. How many
Mm-hmm.
B are there? How many A's are there? And I'll calculate the entropy again. Oh,
Okay.
so is that clear?
Mm-hmm. Yeah, so that makes sense. So on the first one, so since we have the entropy of point 0.9, which is close to 1, right?
Yes.
Does that mean that we will branch, make
uh,
another
that's close
division?
to 1, but I will have to split the I will have to means include all the feature, that patient ID, age, sex, BP, cholesterol also.
So you want to make a decision tree for all the
Yes,
features
yes,
first, okay, and
yes,
then calculate the entropy
yes,
for each.
exactly. So which one should be the splitting point? They are calculating one. Still, they have not concluding that this cholesterol will be the first splitting one. That we will see later part. So first they are calculating the entropy for each feature which is having less entropy. So now they are doing the same thing for 6 feature. So with respect to 6, how many drug A is there with respect to,
Uh,
so machine is doing
okay, so first feature was for cholesterol,
hmm,
right?
yes,
And A and B.
yes,
Okay,
randomly
and
they
then
just picked it up. Randomly they just pick for BP and again, and now they are comparing that 6 is having less entropy or cholesterol. So they see that the as compared to this one cholesterol, which is the having less entropy over there.
So how did they get the six? Let me see. So for it says 6B for cholesterol. 6B. So 1, 2, 3, 4, 6B for cholesterol. How did they calculate? Okay,
Should I?
normal.
Yes, I'm going to close it again.
Yeah, just
Y-
one more time. Yeah.
yes, cholesterol for normal. Just wait. So for normal 1, normal A.
Mm-hmm.
So this is normal A.
Normal A.
Only 1 2.
Okay. Mm-hmm.
Yes, only 2A.
Mm-hmm.
And when we talk about normal B, so normal B1, normal B2, normal
Oh,
B3, normal B4, normal B6, 1 2
okay.
3 4 5 6.
Okay. That makes sense.
Alright, I am going to remove this one. This is not
Mm-hmm.
normal B. So this is normal 1 2 3 4 5 6 are with respect to normal only.
Okay. And we do the same for high. Okay, that
Same.
makes sense. So normal high for A and high for B.
Exactly. But this is
Okay.
not the conclusion part, they are checking randomly.
Mm-hmm.
So
Mm-hmm.
now they are comparing the in between the entropy of cholesterol for both normal and high features, and then entropy of sex for female and male. So out of these two, which one is the uh, better entropy? Which one have the lower entropy? Because I said the one will have the entropy which is having equal choice. I said 0 will have, then it will have polarity on the
Mm-hmm.
single handed.
Yeah, so the sex will have the
Yes, less
the lower
entropy.
entropy.
Yes,
Yep.
so they choose the 6. So now
Lower
the
entropy.
tree is the higher information gain after splitting. So what's the higher information gain after the splitting? That will be split again.
Okay. The sex. Mm-hmm.
Yes, so again.
Oh, okay. So one that's higher. No, hold on. That's not the higher. So the cholesterol will have the higher entropy, right?
Hmm,
Um, because that's closer to one. So they're
hmm,
gonna split the one that has the higher,
hmm,
not the sex. They're not gonna split the sex again.
hmm. No, they are just checking the means information gain of cholesterol only, because they have not concluding anywhere.
Okay, okay.
Because here
Oh, so there's no conclusion right now.
no
Okay,
conclusion right now, because
okay,
here they
okay,
are just calculating the gain information gain of sex
okay.
information of cholesterol rate. Now
Got it.
information is just opposite to the this one entropy. Which one is will
Mm-hmm.
have the higher information gain will split next.
Okay, okay. That makes sense.
Okay, so information gain of sex is going to calculate using that 9, that is 7 upon 14 0.985 of that is entropy of this
Mm-hmm.
female, and 7 upon 14 again, that is
Mm-hmm.
the entropy of this male with respect to male.
Mm-hmm.
So that's the information gain of the sex.
Okay, information gain formula is different than entropy. Okay, so
Exactly.
it is different. Okay, so the information gain. So what is it? Sorry, what does it mean by information gain?
Information gain is something uh, okay,
I think there was in the definition that you sent out. I
Yeah, yes. Information
I
gains
have it.
information that can increase the level of certainty after splitting.
Got it.
Okay, so we can understand in either way. Like suppose I'm going to scroll down a little bit. Suppose I am having table like A's, and then
Mm.
having like any other like salary. All right, so A's is like suppose 36 and salary is uh, like $45. Similarly, if I am having A's is 42, salary is 59. I am having two inputs only. Then I am having
Mm-hmm.
A's is 32, salary is $72. Randomly data is there. Similarly,
Mm-hmm.
A's is suppose 41, so my date salary is $83. So what I will do, let's say this is the splitting point. This is the splitting point. So I'll say that the A's which is having less than 36 or less than equal to 36 will go from this side, and greater than will go from the this side.
Mm-hmm.
So this is no, this is yes. On the left hand side I will have the true value, and on the right hand side I will have the false value, and here I am having
Yes.
that condition. Okay, so here I will have only one. So one data is there and four data is there.
Yes.
Alright, or suppose I
Mm-hmm.
say that salary, so instead of this quantitative data, let's say I am having category data. So no, yes, yes. So here I am having yes only, but here I am having two yes but one no. All right, so this 36 is not very much effective for my data. For this
Mm-hmm.
splitting
Mm-hmm.
point is not very much effective because I am here only one data set,
Yeah.
and here I am having three data set.
Mm-hmm.
Is that clear?
Okay.
Next time I'll take the next value 42. So instead of this 42, I'll take the value that is less than 42 will go on the left hand side if this condition is true.
Mm-hmm.
On the right hand
Mm-hmm.
side I'll take the no values. So
Mm.
I'll divide my data set again, that is yes, and how many yes I am gaining, how many no's are gaining
Two.
for this condition age is less than 42.
Mm-hmm.
I'll check
So you'll
this.
get two, four,
Yes, so
and
I'll
two and two, right?
yes, two yes no and two yes yes on the right hand side. So I can make my decision on the left hand side but not on the right hand side. But my objective is to make all these data is all the yes on the right hand left hand side or the right hand side, or all the no's on the right hand side or the left hand side. Means this yes and no should be polarized. So
Mm-hmm.
so my splitting should be like this. Okay, so in order to understand this thing, they we have this.
So aren't you so goal is to lower the entropy,
Yes.
right? Because if you have one and four,
Mm-hmm.
and then you looked at the next variable that gives you two, two, that means that you're gonna keep splitting it until you
Mm-hmm.
lower the entropy.
Would you say it again?
So I guess your goal is to lower the entropy by splitting.
Yes, and higher the gain, information gain.
Higher the information gains. Lower the entropy, higher the information gain.
Yes.
That's true. Okay, that makes sense. Okay.
Alright, so that will create more.
Okay, now
And
understand.
building decision tree, I think. What is the next?
Okay.
Okay, so coming towards the next, so loading data set and feature selection. So then we are having this tree. So on the
Mm-hmm.
right hand side we are having this
Got it.
decision okay, so when
Mm-hmm.
I talk about this glucose is less than 129.5.
Mm-hmm.
Okay, so I'm going to write here 129.5. So all these values lower than 190.5 goes this side if it is true, and all the values higher than 190.25 will go on this side.
True.
That is entire data set, that is entire tree, decision tree,
Yep.
that's applicable.
That makes sense.
But my question is, we have one question here, that how we are getting this 129.5 value.
I want to say it's your data, right? How is picking up the
Yes,
one entropy that has
yes,
the lowest entropy.
yes. Can you see this? Can you see this glucose kind of
Uh-huh.
data? It's a
Mm-hmm.
148, 85, 83, 89,
Mm-hmm.
137. So doing the same process like this one here,
Mm-hmm.
let's
Mm-hmm.
say this is the glucose level and this is the next level.
Mm-hmm.
So they are doing with the same data set here.
Yep.
Recursively they are taking first variable like 148 and going to polarize for this level 101010 and check.
Mm-hmm.
So on the left hand side there is only one level, and rest of the rows are going to the right hand side from this side. So
Yep.
they check the entropy again, they check the information gain again, and checking that no, this is not the correct way to
Mm-hmm.
go on the splitting. They are checking, system is checking the entropy on the right hand side, system is checking the information on the right hand side again. So they see there is no conclusion. Now they leave this 148 and checking for 85 again. So now on the
Mm-hmm.
left hand side two data is there, that is 1 and O.
Mm-hmm.
So they are checking that E and I again and E and I again. So they are taking 183 in the third iteration. So now three data set on the third on the left hand side and rest of the data on the right hand side.
Got it. So they keep doing that. Um, okay. Until
Yes.
they
So
calculate the one with the lowest entropy. Okay.
yes. So this is how. And also what is the value here? That's the f- 14 192
Uh-huh.
44. This is the root.
Okay.
All right, so
Oh,
how,
Sam. Yep.
yeah, yes, so how we are getting this value 149? Okay, so how many samples are there in our training dataset, because this decision tree is created using training dataset only,
Mm-hmm.
there is
So we
no.
have 537.
Yes, so 500, 537. All right,
Uh-huh.
so now I am going to define that 354 upon 537 into 1 minus 354 upon 537. This is the first class and this is the second class, means this much is for level O, this one is for level 1.
Okay, 1 second. Let me look at this again. Value 354, which is the value for the glucose. That's not the total sample. So 354 is the value. Uh,
300,
Hold on.
500.
When you say value, where are they getting the 354? Is it does it mean the row?
um, row, row for level 1, or there would be low for J, means out of 537 how many label with O is there, and out of
Oh,
537 how many labels with 1 is there. That is the 354, and what is the next value there, and 183. I'm not sure, we're sure pretty much about that respective value for 354 and 183, but
yeah.
that's the fact that 354 is for O and 183
Mm.
is for 1.
Okay. So I think what was confusing me is when I go to the next one, it says 180. Um, sorry, hold on.
Yes. Yes, what's your question?
Yeah, I think what was confusing me was the. Okay, so I understand 354 and 183 are yes and no. So 354 divide 537, which is the total. 1 minus that 354. Okay, and you get. Okay, so what was after you do this solution?
Hmm.
What was your answer? 180.
Okay, so I'm going to calculate this. 354 divide by 537, then
Uh-huh.
multiply it 1 minus, and then 354 divided by 537, and the parenthesis. Yes, that's correct. Control C, and then plus control V. What is the next value? 183. I will have to remove this thing. So
Uh-huh.
183, then 183.449.
Yeah.
Is it 0.449 here?
Mm-hmm.
Guinea index is 0.449 is there. Can you see that?
So yes, I did. So Guinea is the same thing as information
No.
gain? That's
Guinea,
different.
that's different. That's the third thing.
Okay. Okay. Yeah, I see the 0.449. Yep.
Yes. So how they are calculating? They are calculating using these formulas. It says they are given all these formulas is there. Guinea is like summation of
Yeah.
d1, d2. So
Mm-hmm.
Guinea is okay. Just we can go through this site again. So Guinea is like probability of first A split information. How to Guinea ratio information gain. Here we are having information gain.
Mm-hmm.
So this is the formula for information gain. More likely to, you can say that mm, uh, that what was that, entropy, we can say.
Mm-hmm.
So on the basis of information gain they are going to information d minus information particular event,
Okay.
then
Mm-hmm.
finding that ratio information gain is biased for the attribute with many outcomes. It means it prefers the attribute with a larger number of distinct values.
Mm-hmm.
For instance, consider an attribute with unique identifiers such as customer ID has zero information div because of pure partition, because there would be evenly distributed. They maximize the information gain and creates usual partition. So the alternative is gain ratio.
Uh-huh.
Alternative of this information gain. If we are not going to create any conclusion, so then we have that information gain.
Uh-huh.
Okay. So is that clear?
Uh-huh.
So now on behalf of this 3, 5, 4 and 5, 1, 8, 5, 8, 3, they are going to divide again. Can you see that BMI and this BMI?
Uh-huh.
So this is again
So
again. Yes.
one more question, sorry.
Yeah.
Um, so when we did the decision tree, how does the decision tree decide that it's going to first split is going to be glucose? Why not the other feature?
It just
Could it split by male, female? Could
yes.
it split by
Yes.
anything else?
Yes. There are so many so many columns. Yes. So many columns are
Uh-huh.
there: pregnant,
Yep.
glucose, BP, skin.
Yep.
Okay.
Mm-hmm.
So it started, let's say it started from A's.
Mm-hmm.
Alright. So in A's, they just calculate the entropy on the left hand side, and they just calculate the entropy on the right hand side by splitting these 1 and 0 only. And
Mm-hmm.
they just find that okay, this is the entropy. So we were having that comparison in this file, that they were having comparison with A's, with that sex and cholesterol.
Mm. So you're saying that they tested out each decision
Yes.
tree, test out each feature
Yes.
to see which one has the highest what's the number that I'm looking for? Entropy.
Yes.
So it will start from the highest.
Other side.
So it first let's check the sex attribute with respect to target variable. So in that data set, that is the label here, that is the O and 1 only. Instead of drug, they are having
Mm-hmm,
label
mm-hmm,
O and 1. So doing
mm-hmm,
the same thing, first they check the entropy, the whole entropy for level 0 individually, that is O and 1.
mm-hmm,
Right. So they found something, they will found some value over there. Then they found, by splitting this 6 over the O and 1, what would be the entropy. They found okay, we will find 0.98 and 0.541. Then they took the second attribute, let's say cholesterol, and they
mm-hmm,
find the entropy again
mm-hmm,
and compare these two.
mm-hmm,
If it is there, so they will take the third variable, that is BP, and again fourth variable, that is A's. And out of these five, which one will have the less entropy, it will choose first.
Which one will have the less entropy?
Yes, because entropy is lying between 0 and 1 here.
That makes sense. Yeah.
Yes. So if I am having bias, means suppose I am choosing that cholesterol or choosing something else, my my polarization means on the both tree, on the both hand side, my tree will be like this one, like this one, uh, 3 and 5. So I won't be able to conclude anything.
Yeah. Yeah. So he wants to pick the ones with the lowest entropy,
Yes.
so it can split more. Okay.
Yes. So entropy is high. Okay, I'm good with that. Entropy is low here, 1 and 7. But using 1 and 7, I can't conclude anything. still I am
uh-huh.
in an uncertain condition. I am in dilemma, I
Yeah.
would say. So I want to
Mm-hmm.
remove that dilemma and come to yes and no condition only, because
Mm-hmm.
once go till the leaf node, I will have either O level or 1 level.
Yeah.
So they want such kind of attribute which is having more polarization form.
So, hold on, say that again. So zero and so with the first one, the entropy is low. With the zero, you cannot make a good prediction,
No,
right? You
this
can't
is
tell.
acceptable. This is not practically possible, I would
Yeah.
say. This is not practically
Mm-hmm.
possible. My data cannot be in this form that all the male will conclude will consume that drug A and all the female will drug B. No, there might be
Mm-hmm.
possible that few females are also consuming drug A,
Mm-hmm.
but optimal solution would be there. What's the optimal solution? That is, in my case, I would select this entropy. Entropy is low. So this is not possible in the very large data set, and we are
Yeah.
having that means that means discrete data set or very random data set or mutually exclusive data set.
Okay. Okay. So
So this
okay.
is almost, but my theoretically it is saying, theory says that it should be entropy should be equal to 0, but that's not possible. You can see that my entropy is tend towards 0 0 0 9. So I would say it's a much better than entropy with
Mm-hmm.
0.12. So
Yeah.
I would select this.
Ah. Okay. Okay. So okay. So going back to the decision tree. Um.
In
So
our IP1 file.
oh, yeah, that one. So
So what's the first value here in the decision tree? I'm
they
going.
have the L. Um.
Hmm,
Yeah. L stat. Right. Which is the lower status of population. So they started with that.
okay, I can open it. New
Okay.
file. Yes. So how many? One, two, three, four, five. So total five length is there. Okay. So L state is kind of
Uh-huh.
14.915. So all the values less than or equal to 14.915 would go on the left hand side. That is true. And all these
Uh-huh.
values higher than this value will go on to the left hand side, right hand side.
Uh-huh. Uh-huh.
But question again, we can understand that how they are obtaining this 14.915.
Yeah.
So by calculating one by one, so using this individually, so using this
Uh-huh.
they are saying okay, so okay, I am going to create, I should create one more file over here. Okay, so suppose I am having that what is the data set? Yes, that is in LST. Yes, suppose if someone is having A's and someone is having um, gender.
Uh-huh.
So if anyone is having third, so that's very bad example, I would say. That, okay, for example we can say it is, those are having A is 32,
Yeah.
so it is having O, those are having
Uh-huh.
35, it is having female, or those are having 53 is, that is having 0. Those are having 59, that is 0 again. Those are having 35 is, that is one example. So first they took this 32 as a threshold value. So they said in the root node that all the values less than and equal to 32 will go towards the left hand side. Okay, they just checked that only one is there, then none value is there, and they said that all the data is having O, then 1, then O, then 1, then 1. So this is the first condition, this is the first value for the is. So they said that the entropy is very much high or low, that's not balanced one. Entropy of this one is also true, this one entropy of this one is also very confusing, because I want to avoid that situation. This one, 3 drugs 5 drugs B, so I am in this condition. Can you see the right hand side? That is the that dilemma condition. Okay,
Yep.
so what I will do, I will create one more threshold value for me. So at the root I will choose the next value there, 40. So I will choose 40 is less than 40 will go on the left hand side. So
Yeah.
I say
And you
that
do the same thing for.
yes,
Okay.
35, 53, 49. So so the computer is going, computer is doing, the Python code is doing the same thing for us. So they are obtaining the 14.915 optimal value, or the best value we should say.
Okay. So on the left-hand side, so LStat, the one on the left-hand side, it means that's a true.
True with this condition only.
Yeah, with this condition. Hold on. So how do we know which one is true, which is false?
Okay,
Right-hand side
so
is
I
true.
I'll read this data set again. Going towards. I should go towards this one. Okay, L state is the where is L state? Let's do yes. Read the yes. L state is there.
Uh-huh.
Yes.
Uh-huh.
So it will read first row. So it will have that 4.98. It will goes to the left. It will read 9.414. It will go to left again, again left again, again left again. But this median row will also goes to the left. So I would say this entire row is going to the left,
Left side.
and this row, entire row. So stating that this L state is going to the left, that would be wrong statement. I would
That's gonna
say
go to the right.
exactly. I should say
Uh-huh.
completely this entire row is going to the left. This entire go is going to the red. This entire row is going to the red, left again. So the same thing for rest of the data set, the rest of the rows also. If we have tail also, information, we are having 506 entries, so it will do the same thing on these. Okay, so once all the rows and columns are splitting on the basis of L state, it will just, so these rows are having all the red dis A's also. Is that clear?
Mm-hmm.
So on the basis of this node next, this is going to split again. Can you see that node is also here, node is also here, sorry, rm is also here, and crm is also here, rm is also here, nox is also here.
Yeah. Our total data that we had was 354. Okay. Right. Let me double check. no, 506. So we have 506 total.
506 multiply point 0.7, that is 354.
That's right. Yep,
So
yep, you're right. Absolutely. Okay.
this is
I didn't think about that.
this decision tree is created on the basis of training data set only.
Hmm. And the LSTAT and this decision tree is also based on the LSTAT that is going to be less than equal to 14.9. Anything over 14.9,
Will go
it's
there.
not. It's going to
Right hand side.
the right hand side. Okay. So hold on. Let me make a note of that. Um, so it's greater than, less than. Okay. Okay, that makes sense. Okay, now we can go. Okay, so anything that's over 14.9 is going to go to the right side. Any under 14.9 is going to go to the left. Okay, and then we go into node number 1. So now it's going to further divide. Okay.
Alright, and the Gini index is calculating it in each node. How we are calculating that Gini index? That depending upon the sample data set versus the
Mm-hmm.
splitting one. So this value is actually Gini index.
Okay, that's the Gini index.
Hmm.
Okay. And this is all comparing it to, because our y variable, dependent variable, is our median house price, right? So we can say that, so starting from the first one, LSTAT, so we can say that 14.9%, if the LSAT is um, less than equal to 14.9, the median price of the house, it says, then the prices of the property are high,
Hmm.
which makes sense. Okay. Because when we looked at our data,